Hi, and welcome to section 1.2. We're going to be talking about measuring in this lesson. So first of all, you got to warm up. If you want to pause the video, read through that, come up with some answers to those questions, and justify your responses with that. Just know that in a lot of times there's going to be more than one right answer for questions in this class. So take a look at that and come up with some answers for what you think. So 1.2 question is, how are we going to get good data? So emphasize, how are we going to get good data? That's what we're looking for. Not just any old data. We want good data that we can use, that we can justify the use of. Learning target, we can determine if a measurement is valid. So that's what we're going to be talking about as we work our way through section 1.2. A measure. We measure a property of a person or thing when we assign a number to represent the property. So if you look over here, I have some gadgets and gizmos. Thermometer, we're assigning the heat or the temperature, energy levels of something. We've got scales, we can measure the weight of something. We've got a tape measure, length. We've got, I can't remember what those are called right now. A cylinder, a beaker maybe. Measure volume. So we've got all these things here that measure, that we can use, and that's the property of a person or a thing. Right? We've got all these different ways of measuring, all these different measurements that we can take that are going to vary from person to person or thing to thing that we're interested in looking at. The instrument is what we're actually going to use. This is what is used to make a measurement. So up here we had that picture here, and we kind of talked briefly about all those. Down here we've got some more with some different properties. Length. You got tape measures. Time, you've got minutes, seconds, hours, years, and so on. Money, you've got different money that you can count with. Perimeter, area, and you've got your square inches, square feet, all that stuff. Temperature, Fahrenheit, Celsius, Kelvin. Weight, you've got your weight, grams, kilograms, pounds. Volume, think three-dimensionally in that case. How much space do we have in something in 3 dimension, and then angles. So on top of other things that we have, but here's just some good examples for you to look at. And within these, we may have a choice of the units we use to record the measurement. So let's just zoom in on length, as we talked about just a minute ago. Length, you measure how long something is. We have the choice of, in length, we've got centimeters, we've got inches, we've got feet. We've got a lot of different ways that we can measure length, and in time, money, and all those other ones we do. So we may have a choice of units that we record the measurements with. Variable. Talked about variable in the last section. It's the same thing. It's a result of a measurement. It takes different values for people or things that differ in what we are measurement. Like I said, this was the same as our last section, so no new information there with that. But just to refresh your memory on what your variable is, and that's going to be different. When we use our instruments to measure, that's going to be different from person to person or thing to thing. Valid measurements. A measurement is valid if it is relevant or appropriate as a measurement of that property. Valid measurement, if we looked over at this line over here and I said, okay, what's the, measure that line, you wouldn't look at that line and say, oh, it's 7 pounds, right? You would go and you would get your tape measure, and you would go, where was it? You would go and you'd get your tape measure and you'd measure it, and depending on what you're looking at, what screen or if it's projected or what you're looking at, that's going to say, let's just say it's 2 inches. On my iPad, it looks about 2 inches. So we can use that, or we can say, 5 centimeters or so on, whatever the case is. That would be a valid measure. We'd be measuring it in length. We wouldn't say, okay, that line's about 5 seconds. That doesn't make any sense, right? Seconds, time is not a valid measurement of length, so we're not going to use that. So valid measurement is appropriate of the property that you're talking about. Rate, we're going to use rates. Fractions, percentages, or proportions at which something occurs. These are going to be more valid measurement than a simple count. So it gives you context when you talk about rates. So if you think about, Buffalo High School, and if I said, all right, 7 people wore black shirts, Okay, I don't know if that's a lot or if I don't know if that's a little bit. But if I said, okay, 7% of the students at Buffalo High School wore black shirts, that gives you some context. You can say, okay, that's a low percentage or that's a medium percentage. That's that. Just like if I said there are, 10 people with black hair, and you would kind of take that statement, you'd be like, okay, I don't know, should I be impressed with that or not? But if I said 10 out of 10 people have black hair, I'd say, okay, that's a lot of people with black hair. If I said 10 out of a million people had black hair, I'd say, okay, that is not a lot of people with black hair. So that proportion or that fraction, the percentage, it makes it more valid because it gives it context than the simple count. So it gives it the context so you can wrap your brain around it. Predictive validity, we're going to kind of gloss over this one and move on, but just to give you an idea of what predictive validity is, it's used to predict success on tasks that are related to the property measure. And one that we can look at that makes sense to you is SAT and ACT. So those tests have predictive validity. So what it is, ACT, you get a score. Let's just say you get a 24 or whatever. Okay, that score is used to predict your success as a college freshman. So the ACT has predictive validity. The higher you score, the higher chance you have to be successful as a college freshman. SAT, I'm not entirely sure what the scoring range is there, so I don't want to give you a score and have it not make any sense. But SAT is same story. Whatever the 24 equivalent to the SAT is, you could use that, and that could be used to predict success as a college freshman. Oops. So predictive validity, it's a score that is used to predict something else on tasks that are related to the property measure. And that's really all we'll talk about that. So just know that that's out there. Bias, this is going to be a systematic over or understatement of the true value of the property it measures. So bias, systematic, it repeatedly happens. It is repeatedly over or understating the true value of the property it measures. So if you have a scale at home, you step on your scale and it repeatedly reads 5 pounds heavier, right? You always take your weight, whatever your weight is, and you say, all right, I'm going to take that weight and I'm going to subtract 5. So if you weigh 200 pounds, you step on the scale, all right, this scale is 5 pounds heavy, so what you're going to do is you're going to take 5 off, and that's what your score or what your weight would end up being. 195 is what you think. Another one that we always have fun with is the clock on your car. If the clock on your car is off at all, so let's just say, and sometimes I've in the past have had students that have had some pretty wacky numbers here, but let's just say that the clock on your car is 2 minutes fast. 2 minutes fast. So it's systematically overstating the time by 2 minutes. Now, you can count on that 2 minutes to be there. So, you're coming to school and you look at the clock and you see that it's 8:40. Well, in your head, okay, it's actually 8:38. And you do those calculations pretty quickly because you're used to that consistent bias of your clock. It's 2 minutes fast. Bias. It's systematic over or understating of the true value of the property it measures. So bias is going to be a big one as we work our way into surveys and experiments in the next few chapters here. So have a pretty good grip on that. Reliable measurements, these measurements are reliable if they have small random error. So even if it is biased, if you can count on that biased, it's reliable. So whether it's going to give you the measurement that's right on every time, or it's going to give you that measurement that's biased one way or another. So if you can count on your car clock being 2 minutes fast, you know it's 2 minutes fast, and you can rely on that being 2 minutes fast. So it consistently gives you the same bias or no bias in that. So if I had a scale at home, I knew it was 5 pounds heavy. 5 pounds heavy. So what I'm going to do is I'm going to take, I'm going to step on the scale and I'm going to take 5 off. Now, if I had an unreliable scale, I'd step on it one time and it would say 200 pounds. The next time I'd step on it, it would say 192. The next time I'd step on it, it would be 204. So you can see that those are not reliable. Those don't give you a consistent measure of what's going on there, where the bias, you can be reliably biased with that. But if it's unreliable, you know, it's going to be above, it's going to be below, it's going to be all over the place, and you can't really get a good read on that. So, you know, if your car clock, if you turn it on and it's 10 minutes fast, you turn it off, you turn it back on, it's 20 minutes slow, you turn it off, you turn it back on, it's right on. You can't count on it. It's not reliable. How do you assess measures in errors in measurements? So you can look at this in just a second here, but given the measured value, takes into account the true value. So there is an actual true value. So let's just use my weight, for example. I have a true weight that is out there. I don't necessarily get it exactly from the scale because there's bias and random error at play, but there is some true value. Then there's either going to be plus or minus some bias in the instrument. So my scale, you know, we talked about that being like 5 pounds heavy. And then there's just random error. Sometimes it sticks. You know, your springs might be a little worn out or something that goes on there. There's random error. That's the thing that's going to be different from time to time every time you step on the scale. And it's reliable when this random error is small. Small is reliable. So let's just say I stepped on the scale and it said 240 pounds. Okay, my actual weight, not entirely sure what that is. Let's just for the sake of this, let's just say it's, you know, 238 is my actual weight. Now my scale has a 3 pound bias. It's going to add 3 pounds every time I step on it, and then the random error is going to be small. Let's just say that that's going to be a -1 in that case. So the measurement that comes out is going to be 240. My actual weight is going to be 238. There's a 3 pound bias and there's a random error there. So the reading on the scale is this one, but there's all the factors that go into play there. So you can read through this. What the instrument says, this is the real measurement that we don't necessarily have because we're relying on the instrument to give us that. This is going to be regular or consistent errors, and this is going to be random slight variations. And I say slight on there, we're assuming that this is a reliable instrument. So using the average, so the average of several repeated measurements is more reliable than a single measurement. Why? Because no measuring process is perfectly reliable. That means that there's random error. It could be small, but random error exists in all measurements. So what we want to do is we want to measure, we want to use the average of several repeated measurements and see that it's reliable. Then we can average them out and we can get a good measurement with that. So that right there is our section 1.2. So what you got out of this, how do we get good data? We're building up to that as we work our way through. How do we